These are the answers for the 5.11 Chemistry and Medicine fact file for CCEA A2 Chemistry. So, explain the role of EDTA in treating blood. Well, what it does is it sequesters the calcium ions in the blood, which prevents the blood from clotting. 2 marks for that. Question 2. Succinic acid can be analysed by converting it to the diethyl ester and submitting the ester to GLC analysis. So why is it better to use the ester rather than the acid in GLC analysis? It's pretty straightforward. It's because the ester is more volatile, so it passes more quickly through the column. And explain the results expected if the sample of the ester was 90% pure. Well, if it was 90% pure, we would expect one peak with 90% of the total area under it, and then the other 10% would be under different peaks. So 1 mark for stating each of those things. So next question is a huge big long one about the method for production of aspirin. So it says aspirin can be prepared by reacting 2-hydroxybenzoic acid with ethanoic anhydride in the presence of concentrated phosphoric 5 acid. So the product has a melting point of 135 degrees. And we see here, this is the 2-hydroxybenzoic acid, the ethanoic anhydride, and then the aspirin and the acid being produced. So the following method can be used. 2 grams of 2-hydroxybenzoic acid placed in a pear-shaped flask. Add 40 cubic centimetres of ethanoic anhydride. Safely add 5 cubic centimetres of the phosphoric acid to the mixture. Heat under reflux. Then add water to hydrolyse any unreacted ethanoic anhydride to form the ethanoic acid. Pour the mixture onto 400 grams of crushed ice in a beaker. The product is removed by suction filtration, recrystallised from water and dried in a desiccator. The melting point is then determined. So suggest the role of the concentrated phosphoric acid. Well, it's there as a catalyst. Then explain how you would safely add the concentrated phosphoric 5 acid. You would do it slowly, and then the second mark is either for with constant stirring or with cooling. And what's meant by the term reflux? So it's repeated boiling and condensing of a reaction mixture. Then you're asked to draw a labelled diagram showing the apparatus used for refluxing. So I've shown here, I've tried to be as neat as I can, it's tricky on the iPad. We have the little pear-shaped flask here, and then the condenser on the top, and you see I've written water in at the bottom and water out at the top, and then heat underneath for the heating. Okay, so that's the diagram you would need. And how it was marked, they said if there were no gaps around the flask, that was 1 point. Water in at the bottom and out at the top is another point. Open at the top, so nothing in the top of it. And then heating for the contents of the flask. Any errors sadly lost 1 mark, so again be careful with these. Then write an equation for the hydrolysis of ethanoic anhydride. So the formula was given in the last page at the start of the question. So it's CH3CO, brackets, that's all twice, and then oxygen, and H2O, and this is giving 2 molecules of ethanoic acid, CH3COOH. Why is the mixture poured onto the ice? Well, that's to crystallise the aspirin. Then it asks why is suction filtration used rather than gravity filtration. 2 things you could say: it makes a drier product or it's faster, either of those. Describe how the impure product then is recrystallised. So with any recrystallization, you're talking about adding the minimum volume of a hot solvent. In this case, it's water. Then filtering the solution while it's still hot and then cooling it to crystallise. So 3 marks for that. Next little calculation. Assuming 65% yield, calculate the mass of 2-hydroxybenzoic acid required to form 5 grams of pure aspirin with an excess of the anhydride. So our theoretical yield then for the hydroxybenzoic acid is, we've got 5 grams to start with, and that's 0.65, which is 65%, which is 7.692 grams. So sorry, that was for aspirin. So then the mass of the aspirin, the moles of the aspirin would be 7.692 divided by 180, which is the formula mass of aspirin, which gives us 0.04273 moles. So carrying that forward to find the moles of hydroxybenzoic acid, it's a 1-to-1 ratio, so it's the same number of moles, 0.04273. So then the mass of the hydroxybenzoic acid is 0.04273 times 138, which is its formula mass, which gives 5.897 grams. And again, losing 1 mark for each error. Finally, we've got this about cisplatin. So it says draw the structure of cisplatin and explain how it acts as an anti-cancer drug. There are 3 marks for this, so I'm going to say there's 1 mark for the structure. So you've got platinum in the middle, your 2 chlorines on the same side, and then the 2 NH3 groups on the same side. So cis, of course, means they're on the same side. Then how does it act as an anti-cancer drug? Well, it binds to the DNA. You could say it binds to the guanine in DNA, and it prevents cell replication. So that's for 1 mark. And then the cell enters programmed cell death is for your 2nd mark. So 3 marks in total, 1 for the structure and then 1 for each point for how it acts as an anti-cancer drug. So that's the end of the answers for the chemistry in medicine. Thanks for watching.